Okay, so in this class, we're going to be learning about the constant force model. Before we talked about equilibrium, where the F net at equilibrium, the F net is equal to 0. And that can mean that either the object's at rest or moving at a constant velocity. So if the forces aren't balanced, for example, we've talked about friction and then force applied. If the force applied is bigger than friction, that you're going to have, this is a constant force, you're going to have acceleration based on Newton's second law. F net is equal to mass times acceleration. So you're going to have some sort of acceleration then in these kind of problems. So also recalling, the force of friction is equal to mu times the normal force. This is the other equation that we need. And let's do an example now about a constant force model. Let's say, again, the success criteria is first draw a picture of what you have, then you have your equation. You sub plus solve, and then you would have a sentence. Okay? So here's the problem I have. I have on the ground, I have a box. And this box is 50 kilograms. And I have a guy here, and he is pulling. He's pulling a rope attached to the box, and he's pulling it up. And right here we have an angle, it's 30 degrees. So he's applying a force up. And we're given the coefficient of friction on this one is 0.3. Let's say this is 0.3. And we're given a constant force of 400 newtons. This is applied force. The question is, what will the box's acceleration be? The box is going to accelerate. We also have some friction, okay? So we have our picture. We have a picture plus FBD. So if I were to draw the FBD, it's going to look something like this. We have force of gravity. We're going to have force of friction. The box is going to accelerate this direction, and then we also have our normal force. And we have this force here is force applied. Okay, so that's what we have as the FBD. Now we need to think of the dimensions in x and y direction, because we know this vector here is 30. Okay, so you can actually change your FBD because you're going to have the Fn. You're also going to have this triangle here is FAY and FAX. So we need to determine the components of my applied force, and then you're going to have FAY, and then you're going to have force of friction here. We're also going to have FAX, and then the force of gravity. We can determine FAX because we're given this using SPH4U. We can determine the x component using cosine. It's going to be equal to FA cosine theta. And then FAY is going to be FA sine theta. So now we have our FBD, we have some equations. The next thing that we need to do is determine the x and y equations so that we can determine what we have. So now our equations. We can think in the y direction. So in the y direction, we're going to say up is positive, down is negative, to the right is positive, to the left is negative. So we're going to have F net in the y direction is equal to Fn plus Fgy minus the force of gravity. And in this case, F net will not cancel because it's constant force, so we're going to have acceleration. We're going to have ma is equal to Fn plus Fgy minus Fg. And then you can divide by m. So the acceleration is equal to Fn plus Fgy minus Fg divided by m. Now you may think you can just use this equation and find it, but we can't because we actually know that F net in the y direction is going to be 0 because it's not going to lift up. So actually in this case, we know that F net is going to be 0 because he's not going to lift off the ground. And we can use this. We actually have to find the new one because since I'm pulling up, it's going to change your normal force. Okay, your normal force, if I'm applying this, Fn must decrease because it must balance to the force of gravity. Agree? So if I'm pulling up, you're actually applying a force upwards. So therefore, Fn, the normal force, is going to decrease because there's less weight. There's less weight on the ground. So we need this one actually to determine Fn. So the new normal force is going to be equal to, I'm going to move these over. It's going to be equal to the force of gravity minus the force of the force applied in the y direction. Agree? Because we're going to get a new normal force. So let's do this right now. Force of gravity is mass 50 kilograms times 9.8 newtons per kilogram minus the force applied in the y direction, which is 400 newtons multiplied by sine 30. Terry, can you put this into the calculator? What do we get? When you're calculating that, we can also think of the x direction. The x direction is just going to be F net x is equal to the force of friction minus FAX. This is the same as mass times acceleration, force of friction minus FAX. FAX is the force applied cosine theta. Jeremy, you can do this one here. Acceleration is going to be FF minus FA cosine theta 1 divided by m. Force of friction. We need to find the force of friction. Force of friction is equal to mu K times Fn minus Fa cosine theta divided by m. Okay, Terry, what do we get for the first normal force? 290 newtons. Now, if I was not pulling up, I would have just 50 times 9.8. What is 50 times 9.8? What is 50? 290 newtons, right? We would have 490 newtons. So before we would have 490 newtons if I was not applying a force up. But since I'm applying a force up, the normal force is going to decrease because there's going to be less weight pushing down. So you can see that our Fn has decreased. If our Fn has decreased, therefore there's going to be less friction, because we need to determine the friction. Now, Jeremy, you can put this in. Mu k is 0.3. Our new normal force times 290 newtons, 430 divided by the mass and 50 kilograms. Negative 5.18. And then what would be the units here? Meters per second squared. Okay, we got acceleration. So what does this negative mean? It means that this box is, since we said to the right is positive, it means the box is going to accelerate to the left at a rate of 5.8 meters per second squared. So we need to convert that. We need to convert that into a sentence. So, therefore, well, I'll write it right here. Therefore, the box will accelerate to the left at 5.18 meters per second squared. Okay, so that's kind of what I'm looking for. That you have a diagram, you have a FBD, free body diagram. From your FBD, you determine your two equations, x and y direction. In this case, we want to look at the y direction to determine your new normal force, because it's used in the friction, because you can have less friction. So that is it. You also have to put a sentence at the end.